This is my physics course kind of thing where I'm solving past papers. This one is for 2.1 motion, or so the current syllabus, it's going to be A1 kinematics. I'm only doing paper 1 HL questions. Calculator is allowed for the new syllabus, but for the old one it wasn't. This is the old syllabus, by the way. So a projectile is launched at an angle above the horizontal with horizontal components of velocity vh and a vertical component of velocity vv. Air resistance is negligible, which graphs show the variation of the time of vh and of vv. Alright, so what we're going to do here is, to draw this is going to look like, nope, what am I doing? It's basically starting from here. Projectile launched, constant horizontal component. This decreases 0 and then increases negatively. Alrighty, so how can this be represented in a graph? Well, the horizontal component is VH and it has to be constant. Oh, well, that was easy. It's just D. None of the A, B, or C don't have a constant horizontal component. And we can see that in D as well, the vertical component starts at positive and then becomes negative, and in the middle it reaches 0. And the next question. The graph shows the variation of the acceleration of an object with time t. What is the change in speed of the object shown by the graph? So, this is again, find the area, I think. So, and so this is 12, this is 6. We got like that. We gotta find the area. How do we find the area? Easy peasy. We multiply it to get the entire square first and then divide it by 2. Half base into height. So it's gonna be half 12 into 6. This will give us 36, which is C, and that's the right answer. Next question. A mass is suspended from the ceiling of a train carriage by a string. The string makes an angle theta with the vertical when the train is accelerating along a horizontal track. What is the acceleration of the train? Okay, so, well, how we're going to solve this question is using Newton's second law. So, for the vertical component, the ball's not moving up or down, it's just moving right. So it's going to mean that the downward force, the weight, is equal to the upward force, which is, with theta, it's going to be opposite over hypotenuse, so katoa. So it's going to be tension cos theta. This is for the vertical component, by the way. And then for the horizontal component, it is tension MA, because it's going accelerating forward, is equal to tension into sine theta. We divide the equations by each other, so the t's cancel out, the m's cancel out, and eventually we'll end up with tan theta is A over G. And now we isolate A, and we will get G tan theta, which is C. Next question asks for, a student draws a graph to show the variation of time of the acceleration A of an object. What can a student deduce from the graph only, and what quantity from the graph is used to make this deduction? Alright, so the acceleration is increasing, as we can see. So that means that from the graph directly, always in acceleration and time graphs, the area always shows us the change in velocity. And this supports B. It can't be C or D. So this supports B, and it's not the gradient, it's the area. This is just something from the content. A parachutist of total mass 70 kg, alright, 70 kg, is falling vertically through the air at a speed of 8 meters per second. Nope, just second. What is the total upward force acting on the parachutist? Well, then there's definitely air resistance. And we're going to find this through realizing that it's constant. That means the upward force, so let's just call it drag, is going to be equal to the downward force. And now we need to find, since we have A and F, since we have A and M, well, we just multiply them from F equals MA, and we'll get 70 into 88, which gives us, except, one thing to note here is that even though they give us 8, I made an error here. We're not supposed to use that value. We're actually supposed to use gravity. So it's going to be 70 into 10, which is 700, which is how we get the answer is D. The 8 meters per second that they give is actually a distractor, as it doesn't matter what force, what constant velocity it is, the resultant force is still 0, so this doesn't matter at all. And I fell for it. Alright, next question. Alright, so in the question we are given that the distance is 0.050 meters, and that the time interval is 1. So if we're going to count, then it's going to be 0th, so it's going to be 1, 2, 3, 4, 5. 5th millisecond, which if you divide by 1,000 to get seconds, it's going to be 0.005. So the time interval is 0.005 seconds, and we need to find the average acceleration. Where we're going to use that equation, since the u is also 0, s equals to, ut plus half at squared, and we're going to look for a. So it's going to be 0, and we plug in our numbers, so it's going to be, we can isolate a first. A is going to be 2s over t squared, and if you plug in our numbers, we'll get 0.050 over t squared is 0.005 squared, which will give us around 4,000 meters per second squared, which is B. Next question, and it's going to be, a projectile is fired at an angle to the horizontal. Alright, so there's definitely air resistance because it's not parabolic. Which gives the magnitude of the horizontal component and the magnitude of the vertical component for the velocity between O and P? Okay, so this is just like the SL question, but with air resistance in it. The magnitude of the horizontal component of velocity definitely decreases because it's like it's true, like the horizontal component is trying to push, but the air resistant is going like that, so it's fighting against it and reducing the horizontal component's effect, so it's going to decrease. That means C and D are invalid. So which is it? Between A and B? Well, the magnitude of the vertical component of velocity is going to increase because it's getting bigger, because at the top it's 0. So in my opinion, it's going to be A. Alright. So the magnitude of the vertical is increasing as in a normal parabola, as normal projectile motion. So a boy throws a ball horizontally at the speed of 15 from the top of a cliff that is 80 meters tall, and above the surface of the sea, air resistance is negligible. What is the distance from the bottom of a cliff to the point where the ball lands in the sea? What is this, basically? So this is what we're given. U is 0. The horizontal component is 15. Height is 80. We need to find the distance. And acceleration is 10. So we're going to use the free fall equation. But instead of s, I'm going to use s anyway. Gt squared. And acceleration is gravity, so it's going to be half 10 t squared, which means 80, and t is going to be 4 seconds, simplifying that. And then as we're giving the horizontal component, which is 15, we multiply to get 60 meters, as speed into time is distance, and therefore that's 60 meters, which is B. Next question. A sports car is accelerated from 0 to 100 kilometers per hour in 3 seconds. What is the acceleration of the car? Okay, so 0 to 100 kilometers per hour in 3 seconds. Okay, then the acceleration would be this is a Suvat equation problem, so it's going to be 100 equals to 0, so it's nothing, a through 3a, so it's going to be oh well, no, I did this wrong. It has to be in terms of g. So what we're going to do here is first convert the kilometers to meters. So it's going to be 100 kilometers per hour is around 27.8 meters per second through dimensional analysis. This is multiplying it to the conversion factor of 1,000 over 3,600, by the way. And then we need to calculate the acceleration. Acceleration is change in velocity over change in time. So we're going to plug in what we just found over the time that we were given, 9.26. And then we need to divide this by gravity, as the question wants it in terms of gravity. So 9.26 over 9.81 is around 0.94 or just 9, which is C. Next question. A girl throws an object horizontally at time t0. The air resistance can be ignored at t 0.5 seconds. The object travels horizontally a distance of x in meters, while it falls vertically through a distance in y meters. What is the initial velocity of the object and the vertical distance fallen at t1? Okay, so it's time. In this question, we are given a projectile motion, looks a bit like this. And this is y. No, we need to figure it out. So, what is the initial velocity of the object? How we're going to find this out is that the displacement is given by vt, or the velocity to time, and this is x, and this is given as 0.5. So it's going to, if we use x, Then x is the initial velocity, and if we isolate the initial velocity, we're going to get x over t, which is 0.5, and if we divide it, that means that its velocity is going to be 2x. And then for the vertical component, at 1, we're going to use the free fall formula. It's going to be y at the moment of t is half of gt squared, which is given that at 0.5. So what we're going to do here is plug in 0.5, and we look at that that the y is g over 8. And then if you find the vertical distance at 1 instead of 0.5, then we'll find that if we plug in 1 instead, we'll get that y is half over half into g. So if we get that g is 8y, so y is half g, which is half 8y, which is 4y. So that corresponds with option D. This is the third last question. Ball is thrown upward. What is the height h at the time? What we're going to do here is, so for this question, you are given acceleration is negative g, motion is symmetric, so it goes up and then it falls down at the same place, which means the time to go up is time to go down, aka t over 2. That's the motion showing that it's symmetric. Initial speed u can be found from the time of flight, aka t, and then for an object thrown upward and landing at the same height, t is 2u over g, and which means that u, the initial, is gravity into t into 2. And then we're going to use the free fall kinematic equation. So it's going to be, for the height is, for t, is ut minus, since gravity is negative, gt squared. And then we plug in our the previous thing. So half gt squared. And then we simplify until we get half gt t minus 1, t minus t. And this corresponds with option D, which again needs brackets in it. It's the correct answer. A ball falls from rest in the absence of air resistance. The position of the center of the ball is determined at 1 second intervals from the instant in which it is released. What are the distances in meters traveled by the center of the ball during each second for the first 4 seconds of the motion? So, how we're going to solve the next question is that the displacement for t is given through the free fall equation, and we can simplify this by plugging in g to be 10, which is 5t squared, and then we plug in for t 1 to 4, which will give us 5, 20, 45, and 80 respectively. And then we subtract each by the number before it. So there'll be 5 minus 0 is 5, 20 minus 5 is 15, 45 minus 20 is 25, 80 minus 45 is 35, which corresponds to option number B. The next and last question for this section is, an object is thrown from a cliff at an angle to the horizontal. The ground below the cliff is horizontal. 3 quantities are known about this motion. The horizontal component, and then what are the quantities that must be known? Okay, so let me just draw this really quick. This is the cliff, object dropped horizontal. So what do we know? the horizontal component of the initial, okay, so we know that. The initial angle, we know that. And the height of the cliff, we know that. What are the quantities that must be known in order to determine the horizontal distance from the point of the projection? So we need to know this. How do we find it? Well, okay, distance is the velocity into the time. We gotta find the time. And to find the time, so for this question, we're going to first need to find time, and then since we already know the velocity, we can then find x. So let me write it as. So, how much do we need? Well, we'll need all of the components because to find time, we have to use the free fall equation, which is, so we'll need it, and to find the vertical component, we'll need the angle as well. So the answer is D, 1, 2, and 3. So we'll need to know the height of the cliff, the angle between of the cliff to find the vertical component, and we'll need to know the horizontal component to find the distance through the s equals vt or x equals vt formula. That's pretty much it. Thanks for watching. I'll see you guys next time.